This video is for day 8. That will be Thursday, April 2nd, 2020. We're going to start working on some pretty easy word problems for logarithmic functions. They're going to look very, very similar to you because they are identical to the exponential word problems we did. Well, some of them, except for a little bit at the end on how we're going to solve it. So we've got an investment here of $5,000. We've got an interest rate of 5.5%. It's compounded monthly, and we'd like to know how long until it doubles in value. So our equation, if you recall, was the ending amount is equal to the beginning amount, a sub 0 or principal, times 1 plus r over n, the rate over the number of compoundings, raised to the nt, again, number of compoundings times time. And with money, time is always in years. So I'd like you to list all your variables, A, P, R, N, and T. So it says how long, so we don't know time. We end up with, well, we're going to double 5,000, so we're going to end up with 10,000. And the principal is what we start with. That's our 5,000. Our interest rate is 5.5% or 0.055. Number of compoundings, what's compounded monthly? Last I checked, we got 12 months. So we're going to take 10,000 is equal to our 5,000 here. Simple substitution in. 1 plus 0.055 all over 12 raised to the 12t. So nothing looks different so far unless you can see what it is. I'm going to divide both sides by the 5,000 to give me 2 is equal to, and now on the inside I'm going to take 0.055 divided by 12 and add 1 to it. Hopefully your calculator is as good as mine. And I'm going to get 1.00458 I'll stop there, raised to the 12t. Now the problem is my variable's up here in the exponent. So how do I solve for that? Well, now this is a base, an exponent, and a number. So I'm going to rewrite that in logarithmic form. So I'm going to have a log with this very lengthy base, 1.00458. And I'm going to take the log of my number 2, and that's going to equal the exponent 12t. Well, again, my calculator can't handle this log with this crazy base. So I'm going to use the change of base formula, and I'm going to come the whole way up over here. The change of base formula, I'm going to use a base of 10, so I'm dealing with a common log of 2 divided by the common log, base 10, of 1.0045, can't read that, 83. And that's supposed to equal 12t. Now we did this before, so you're going to have to, on your calculator, take the log of 2. Don't forget to close the parentheses in your calculator. Divided by the log of 1.004583. And I came up with 151.1589 is equal to 12t. And of course, you're just going to divide by 12. And I got t to equal 12.6 years. So very, very similar to the problems we've done, except that log stuff at the end. Okay, our next example is going to actually be a little bit easier because we're depositing into an account that pays 6.5% compounded continuously. That's going to make it a tad easier. And we want to know after how many years it has 1,500 in it. So instead of using our normal compounding formula for compounding continuously, we use the formula that has the natural number e into it, and it's raised to the rt. That takes care of the infinitely many compoundings. So again, we're going to list all of our unknowns, a, p, r, and t. And again, it's going to ask me how long, so I don't know that. That means I'm going to have to use logs to solve this. 0.065 for my rate. Principal, what did I start with? $1,000. And we want to end up with $1,500. So just substituting in, we're going to get this. Okay, dividing both sides by 1,000, it's going to give me the 1.5 equals e to the 0.065t. Again, now we have a base exponent number. We're going to go from exponential form to logarithmic form. Since my base is e, I have a natural log of 1.5 because it's base exponent, exponent number. So I take the log of a number and it equals the exponent, 0.065t. Now, our last problem, we had to mess around with change of base. We don't have to do that. Our calculator has the natural log in it. So when I take the natural log of 1.5, I get 0.405465. That's far enough. And that's equal to 0.065 t, and all we got to do is divide by 0.065 on both sides and get t is equal to 6.2 years. And that's all there is. Again, check Google Classroom for an assignment, and I will talk to you tomorrow. Have a good day. Remember to ask any questions on there. I'll do as much as I can for you. Thank you.